Hello friends, today we are going to do graphical derivation for third equation of motion. So you know third equation of motion, how do we write third equation of motion? Third equation of motion is written as v square minus u square is equal to 2as, where the symbol have their usual meaning. You know, v is the final velocity, u is the initial velocity, a is the acceleration and s is displacement or the magnitude of displacement, which we can write it as distance. Now, since this is a relation between position, see here S will show you the position and velocity, it's sometimes also referred to as position velocity relation. The third equation of motion is also referred to as position velocity relation. So let's derive the third equation of motion. As it is a graphical derivation, we'll draw the graph. Graph is again the same graph which we used in first equation of motion and second equation of motion. That's a VT graph, velocity time graph. Let's see the considerations. Consideration is, let's consider an object at point A on the graph. It's moving with initial velocity u. So this is your initial velocity u. Let this be origin O. A body is traveling with initial velocity u. It's traveling with uniform acceleration. The acceleration is uniform and within time t, it attains a final velocity of v. So what is the final velocity of the object? It's v. AB shows the motion. AB shows the VT graph for an uniformly accelerated body, right? Now, what we will do? We will do some simple constructions for our derivation. The construction first, a perpendicular from B on the time axis, okay, and let me mark it out as C. The second construction is a line parallel to your time axis. See here, this is your time axis, a line parallel to the time axis from point A, and let us mark it out as D, okay. Now, always you should remember where to start the derivation from. Second equation of motion, we have started the derivation from that area under VT graph gives the distance traveled, right? Same here also, we'll write area under VT graph gives distance traveled or the magnitude of displacement. Same thing we will use here also. Only difference is that in second equation of motion we divided our figure as a rectangle and a triangle, but here we'll take the complete figure which is trapezium. Okay, so S is equal to area of trapezium. Name the trapezium A, B, C, O. Okay, A, B, C, O. Now, let's use the formula for area of trapezium. What's the formula for area of trapezium? The area of trapezium is half the sum of parallel sides. Okay, parallel sides into height. What's the formula for area of trapezium, children? So now we'll write area of trapezium half. So let 2 go down. Sum of parallel sides. What are the parallel sides? See from the graph, what are the parallel sides for this trapezium? This is your trapezium, children. What are the parallel sides for trapezium? Parallel sides are AO and BC. So write that. AO plus BC. Sum of parallel sides into height. What's the height? See here. This is the perpendicular. So this much is the height. What is the height? OC. But we don't want A, O, B, C, O, C. What do we want? U, V, A and S. So let's substitute these values from the graph. S is equal to AO. How much is AOC from the graph? How much is AO? It's U plus BC. How much is BC from the graph? BC is V into OC. See here how much is OC? It's time taken T. And half will be as such. Mark this as equation number 1. Okay. Now see here, go back to your what you have to derive. In this, you can see there is no T. There is no T in the third equation of motion. So that means you have to substitute t with something. We don't want t. Let's remove t. Let's substitute t with something. So what do you want? A. Instead we want a. So how to bring a in this equation? We will use first equation of motion. Using first equation of motion. What is first equation of motion? V is equal to u plus at, right? From this you find out the value of t and just substitute it over here. So what will t be equal to? Take u on this side, it becomes v minus u because it was plus. When it comes here it will become minus, is equal to at, and then t is equal to, remove a also, throw a also on this side of the equation, it will become v minus u by a, right? Mark this out as equation number 2. Substitute this value of time which you have just now found in this equation. Okay, so what we will write, substituting the value of t from equation number 2 in equation number 1. So write that. Substituting the value of t from equation number 2 in equation number 1. Okay, this is your equation number 1. Just put this value of t. So what does it becomes? It becomes s is equal to u plus v, and what have you found out? What is t? V minus u. And a was down, okay, a was down and already we had 2 down, so it becomes 2a. 2 was already there and this a comes here, so it becomes 2a. Now this is simple math. See children, this can be written as s is equal to, this is a minus b, this is a plus b. Okay, you know the formula, a minus b, a plus b, it's equal to what? A square minus b square, right? You know this identity. Using this identity, we know this is v minus u and this can be taken as v plus u, v plus u, v minus u. So that will give you v square minus u square using formula, right? So by 2a, just use this formula. Now take this 2a on another side, it becomes 2as is equal to v square minus u square. Or simple rearrangement, if you want to write it the way we have written it first, the or v square minus u square is equal to 2as. This is second equation. This is third equation of motion. Okay, we have derived the third equation of motion graphically. Right? This is third equation of motion. Always in the graphical derivations, you have to remember where to start our equations from, where to start our derivation from. For first equation of motion, you have to start from this BC is equal to BD plus this BC is equal to BD plus DC. For second equation of motion, you have to start that area under VT graph. It gives you displacement. Okay, and area you have to take a rectangle area plus triangle area. Okay, area of triangle and rectangle, then you derive. For third equation of motion also you start from S, but this time you have to take complete trapezium. If you remember this, you can derive the equations very easily. Thank you.